And so what I'm going to be doing is I'm going to record today from my computer so that it will display things a little bit better. Okay. Okay, is this large enough so that people can see, or do I need to make the text larger? Should be larger. Okay. So unfortunately, I'm sorry? All right, so let's see. All right, how's that for size? Okay, so what I want to do is I want to show you how to use Mathematica to do a bunch of things. This does not mean that you should not be able to do them by hand, but this is the 21st century. You would never be doing anything professionally like this by hand. You would always be checking things using a computer package like this. How many of you have ever done a decent amount of programming? How many of you know about the joys of new versions, new releases, new editions, and backwards compatibility? So anybody who has programmed enough knows that things are not always backwards compatible, and that what worked in the past does not always work on the latest version. And so I was testing a couple of things last night, and some of the commands that worked a few years ago, the last time I taught the class, no longer work because they've changed things. Sometimes the changes they make are logical, natural changes. They are good things to do. They're just not good to do once you've been doing the bad thing for 2 decades. Okay? I've talked to, I think, some of you about this before. Who knows, and Kayla, you are eligible to answer questions like this, what this word is? QWERTY.
Like the configuration of the keyboard?
Yes. Why is the keyboard configured to be QWERTY?
So people couldn't type too fast on typewriter?
On typewriters, yes, and he was very fast in answering that question, right? On an old typewriter, if you hit 2 keys that were close to each other in quick succession, they would link. And so this keyboard is deliberately designed to be inefficient and to slow you down. Well, we no longer have typewriters. Why do we still use the QWERTY keyboard?
Because people got used to it, so now they sell software packages that teach kids how to use it.
But why don't we just make the change?
Because we don't like change.
Who is the we?
Humans.
Which humans?
The old people.
The old people. Like, I love you like you're my own daughter, but you know, I'm used to using the QWERTY keyboard. You would need a huge number of people to say, we'll take the hit, we'll learn a new system, rather than pushing the old system on people. This is why we get stuck with stupid things like the QWERTY keyboard. So it used to be called cross product. What do you think the cross product computed for you? The cross product, yes. It's now called cross. So if you do a question mark in front of something in Mathematica, that will give you an explanation of what it is. You can also, of course, do what? If you don't know how to do something in Mathematica. Google it. Right, and that's what I actually did. So it says, doesn't really understand what cross product is, but cross gives the vector cross product of A and B. And if you click on this on the bottom, it expands it out, gives you a little bit more local documentation, web documentation. So if I hit local, it will open up a new window. I'm not sure if that will actually be broadcast on this thing over here. And then you have details, you have examples. So going back over here, what I've done is I've just defined a new function called cross product, the function that I was used to when I was younger. And it takes as inputs 2 things that I'm calling input 1 and input 2, and it now uses the new function cross. So if I forget and I accidentally write cross product rather than cross, it will still compute it. So I've chosen 3 vectors, E1, E2, E3, and I want to calculate the cross product of them. So you normally use a semicolon at the end of the line to mean that you are done with the input, and a semicolon will suppress the output. So if there was something to be printed, it will not print it. If I take away that, it will now print just the first one, 1, 0, 0, and not print the other 2. And now if I take the cross product of E1 and E2 is given as E3. Does that make sense? What if I did E1 plus E2 crossed with E2? What should that be? It should be the same thing. So we have, in some sense, a nice linearity. So I would just write, E1 plus E2 cross E3 is equal to E1 cross E3 plus E2 cross E3. So when you think about what's going on with the cross product, does this make sense? Do you believe this rule? Could you test it?
Yeah.
Yeah. How many entries do we have for the, this is really a more general rule. Vector 1 plus vector 2 cross vector 3. How many components does vector 1 have? 3. How many components does vector 2 have?
Right.
And how many components does vector 3 have?
Right.
So you compute the two different sides and you see if they're the same. Okay. Does that sound like fun?
Yeah.
Yes, it does.
When the computer does it for us.
When the computer does it. So let's have the computer do it for us. So I'm going to do my first vector, and the way I'm going to do a vector is parentheses. I'll do A, B, C for my first vector. And then I'll add my second vector, D, E, F. And what comes after F? G, H, I. And there we go. So does that look right to you? Do you believe that this is the correct answer, or do you think that something might be wrong? You can play Sesame Street. One of these letters is not like the other. One of these letters just doesn't belong. Yeah, it's I. So I is coming in black. Everything else is in blue. Maybe I is being interpreted as the square root of -1. Let me go with J. And we're also getting these 11s down here, and there's no I anywhere down below.
Oh, is this
No, just K. You can do K. Does that look better?
Yeah.
Yeah.
So again, you want to have a sense of what's going on. And why are we doing K? Best letter in the alphabet? Yes. So this was the cross product. Now what I'm going to do is I'm going to subtract off the cross product of the first one plus the cross product of the second one, which is going to be D, E, F, comma, G, H, K. And what should I get now?
Well, 0.
Oh, no, because it's
Yes,
minus.
because it's
zero.
minus. Which 0? 0, the number is 0, the vector. 0, the vector. And so you do shift enter to compile a line, and we get 0, 0, 0. Did we just prove a theorem? Yes, we just proved a theorem. Is this a hard theorem to prove by hand? No. If I give Kayla the rule, and I tell Kayla, I will give you, $100 in Amazon money if you do the algebra, I think she could do it. I think she'd even be willing to do it, right? You just plug everything in, and then you just show that everything cancels. Is there any reason to be doing this in the 21st century? No, unless you're having a stressful day and you find doing a little bit of algebra is relaxing and puts you in a nice Zen state, and just works out nicely, then by all means go through and do this. But otherwise, use the computer. You could also go online to Wolfram Alpha and into stuff like this there as well. So the website, it would be Wolfram Alpha. So search for Wolfram Alpha. Now, if I do it like that and it tries to compile it, it will actually just print that out as text, which is not so bad. I could put it in a print command.
Why is it alpha for search Wolfram?
So it prints it, but it does not print it as the normal way. I was going to say, watch the difference now when I put in parentheses. Now it actually prints it as, prints the string between the two parentheses. I mean, between the two quotation marks. Okay, so if you ever have a cross product on the homework, can you now check and make sure you've done the cross? Yeah, absolutely. Instead of doing the cross product, if you have to do the dot product, you just do dot and you do the two vectors. And again, the way we do vectors is we start off with a curly parenthesis, curly brace, then you do your components, and this gives you your nice vectors. And so down below, I have it calculate the dot product of E1 and E2. Not surprisingly, the dot product is 0. If I did E1 plus E2, what should I get? So dot product of E1 plus E2. So dot product of E1 and E0 is 0 because they're perpendicular. So this is the vector 1, 1, 0, and the vector 0, 1, 0. What should their dot product be? So this is taking too long. So I've got 1, 1, 0 dotted with 0, 1, 0, right? The dot product should just be 1, right? It's going to be the first component 1 times 0 plus the second component 1 times 1. Excuse me, plus the third component 0 times 0. Do you think we have linearity for the dot product? The dot product of v plus w dotted with u is v dot u plus w dot u. Do you think we have linearity? Probably. Should we prove it? Should we start doing it all over again? What's the fastest way to type it? Copy and paste, right? Right? Be lazy. Actually, so what I'm going to do is copy. Well, I won't do it. There's a program I normally use to do my mathematical typing, but if I paste it into that to do something, you would then see the names of all the files I'm working on, which I do not want to be shown. What I would do is I would actually paste this somewhere and just do a search and replace, and everywhere you see the word cross, replace it with the word dot. However, we're talking about 3 words here, you know. So, but I will do those. I will at least highlight it, and then I will just paste it like that.
It's not 0.
So it is not 0. Or is it? So when you look at this, is this 0 or not? We have negative AG minus DG, and we have A plus D times G. Is it 0?
Zero.
Okay, so we think everything expands outward. So let's put in the word expand, which basically tells Mathematica to expand out everything. And now you get 0. Okay, so it takes a while to learn how to play with stuff like this. You know, I was a double geek when I was in college. I was a physics major and a math major. When you do physics labs, you got very good at using programs like Mathematica and Excel. So depending on how you do things, you can prove a lot of things very quickly with this. Now, we only prove things for vectors with 3 components. Can we do things with infinitely many components here? Infinitely many. Infinitely many. It's nice that you have this much faith and confidence. Do you think we could do any finite number?
Yes.
But can we do that? So if you tell me the number of components, I can probably do it on the computer. But what if I wanted to do an arbitrary number of components? Is this going to be approved? That's much harder. And so I don't think this is going to prove it for an arbitrary number. All right. The next thing is to do things with matrices. How many of you have never seen a matrix before? Okay, so it should just be Kayla. All right. So here is a matrix. So you have 2 braces on the outside, and then the first stuff over here is the first row, and this is the second row. When you look at this, brace, brace, 1, 2, brace, 3, 4, brace, brace, does that look like a matrix to you? No. So Mathematica has this nice thing called matrix form, And when you put something in matrix form, it displays it as a matrix. And then DET, what do you think DET calculates? The determinant. So you can do a lot of these things very easily. So I just calculate this. And now I made a little dinky function. I called it 1 to n square. And it has input n. So this is going to be a chance to show you a little bit of basic programming. This is one of the skills you really want to master. Unfortunately, I can't find the program that Kayla and I made. I will have to keep searching for it. We actually made a skating video that we animated. Okay, but that bag is not here right now.
There's only an image.
It is only an image. So we actually had a little skater that went back and forth, and you can put music in and whatnot. And it turned around, and it won gold. Oh no, that was you. So if you can write programs, there's a tremendous amount of stuff you can do. So whenever you have a variable, you have an underscore after it to show that it's a variable. Then colon equals means I'm defining something. So in mathematics, colon equal means definition. So if you say, 3x plus 5 equals 7, you're not defining 3x plus 5. You're just saying that expression happens to be 7. And then module is just the way we say function or procedure or program in Mathematica. It starts with a bracket, it ends with a bracket. How many of you have done programming? So in only one part is this well programmed. What is the one line that is well programmed? It's one of the things that most programmers forget to do. And if they leave the company, it causes a lot of heartache.
The print we have.
Nope. The comment. Only one line actually has a comment that says what's going on. When you are writing a really simple, basic program, you don't really have to comment. It's not that important. When you're writing a very complicated program, and you might need to change things later, or you may not be at the company later, it's very useful to put in some comments. So here, this comment, it's parentheses, star, star, parentheses, starts and ends a comment. Mathematica prints things in different colors, which is very nice. And so this will tell us that this is a comment. So, what I should really do here is end of module. To some extent, that's not really needed because it's the final line. But so over here, I could put in a comment. This will be a matrix until it comes to the end of the comment. So it also indents things as you're going. So if you look at it, things are indented based on where they are. So you start off here, M4, and then this is begin and end of the for loop. So brace means begin, closing brace means end. So temp is where I will store the entries of the row we are constructing. And then for j equals 1, j less than equal to n, j plus plus, the plus plus means j equals j plus 1. Every time we go through this, we increment j by 1. Most loops, you turn out to increment things by 1, or what's the opposite of increment? Decrement things by 1. So how would you do decrement by 1? Minus, minus. You're depending if you want to count up or count down. I like to count up. So j goes from 1 to n. Temp is append to temp. So temp is going to be an array. It's initially empty. There's nothing in it. And then to it, I'm going to add I minus 1 times n plus j. So the first time when I go through this loop, n is equal to 1. I is equal to 1. So initially, I minus 1 is 0. So I'm going to first add 1, then 2, then 3, then 4, all the way up to n. So temp is going to be a list of numbers from 1 to n. And then I add that to m. Add temp as the next row of m. And now I go back and I do the I loop again. I do the command again. And now I equals 2. So I initialize temp again to be 0. And then j goes from 1 to n. Now because I equals 2, I'm going to have n plus j. So I'm going to have n plus 1, n plus 2, all the way up to 2n. And so on and so on and so on. This is going to just give me the matrix from 1 to n squared that we had as one of the extra credit problems. And so now, Shift-Enter compiles it. If you look at this, there should be something screaming out to you that something looks a little bit wrong.
semicolon being purple, or do you mean like the end thing?
So the semicolon being purple is a flag as to why is that purple? There is something else though that should call your attention, something else that's in a slightly different color. Yes, you actually get an extra cookie, Kayla. You can have an extra cookie. The M is in a different color. Why is M in a different color?
It's a variable. So like, well,
N is a variable.
But there needs to be the hyphen, or not the hyphen, the underscore next to it to define it as a variable.
Yeah, we've never talked about M before in this program. What do you think M is supposed to be?
Capitalized.
Nope. What do you think M is supposed to be? Want to guess? This would be 2 cookies. What do you think M is supposed to be? Not a matrix. Yes, it's supposed to be N. Here, we have N equals M.
So what's the point of having N?
Oh, it's a typo. It's a mistake. It's wrong,
Oh.
right? It's meant to emphasize things to you. Did you just hit him?
Yeah.
Okay.
Wow.
We'll talk after class. Yes.
I need to see this.
Oh, then we won't talk after class. Sorry. So I did this deliberately. Why do you think I did this deliberately? This is a class. I'm trying to show you how to use a system. Should I be doing everything perfectly? No. You learn more when you have mistakes. And I want you to be able to just look at things and see what's going on. The fact that this was in a different color tells me I probably want N. I want something else.
Does it matter that we have it defined as N equals N?
Well, this over here is going to be printed out. This is text. It's between 2 quotation marks. That's why I can put whatever I want. You know, I can put something like that in, and Mathematica has absolutely no complaint with that. Right? That is absolutely fine. But if I put an M over there, it's no longer between quotation marks. It's something that Mathematica will go, where the hell did this M come from? And it's flagging it for me. I do not know why we have an issue with the semicolon there. I will try deleting it and putting it in again. No, it's still, I don't know why that's in purple. Now I have this new command. If I type 1 to n square 5, it will compute the matrix. I could do 10 if I wanted a bigger matrix, and there's the numbers 1 to 100. Filled it in. So when I gave you a homework problem for extra credit, you want to build up some intuition. So what we could do, we could put in a little bit more stuff. We could actually do return M. So what do you think return M does?
well, I'm not sure, but in traditional, well, in Java or C++, return returns that value as the function. So maybe
Yeah.
the 1 to n square will now return the matrix. So you can say matrix something.
Yeah, so maybe I could actually just take like determinant of this.
And print 0 at the bottom.
And there's an extra 0 at the bottom over here now. You have to see, it's really cute and little right there. If I don't do determinant around it, it's now returning the value of the matrix over here. If I get rid of this line, it's no longer returning anything. So I can actually have the function returning a nice value for me, which is very useful. Now, I actually put in a few lines of code to actually have it calculate the determinant and write explicitly the determinant is 0. What you might want to do now is build intuition. So the extra credit problem was, if I give you this matrix, as long as n is at least 3, can you notice anything interesting? Now, given that we did not talk about what the formula is for the determinant of a 4x4 matrix, the determinant is always going to be 0. And so what I wrote is a little code for n goes from 2, well, let's do n goes from 3 to 10, have it do this function. And so now it's printing the outputs. And so what you can see is it's printing out all the matrices and all the determinants are 0. This is not a proof that it's always 0. I only calculated up to 10, but it's making us pretty confident that something is going on. And eventually what you might notice is if you take the first and the third row and add them together, it's double the second. So 20 is 10, I'm sorry, 2 times 20 is 10 plus 30, 2 times 19 is 9 plus 29. And then that's an exercise you can prove that the second row is always half of the first plus the third. So what it means is the vectors are not in independent directions. It's not got the right dimension, and so it can't have any value other than 0. All right, so this is just some basic coding. We will get to spherical stuff in a little bit. Well, let's do a little spherical stuff first, and then we'll do some more stuff. So this is what I grew up with, okay? This is a nice sphere. You have your coordinate systems, but you have phi as the angle in the plane, and you have theta as the angle coming down from the z-axis. I think this is a really nice picture to show what's going on. But what angle does our book use coming down from the z-axis? Phi. And what does it use coming in the plane? Why?
Theta is like polar. So
Yes, polar coordinates is r theta. So if you're going to go to spherical coordinates, why not keep the stuff down below the same and then have phi be the new thing coming up?
Why does this change?
Because physics uses often a different notation, and they often use theta coming down. You have to be extremely careful about what books you're using. I'll share this. When I was a postdoc at Ohio State, the professor I was working with had a graduate student who was working in the same field that I was. And he finished his thesis and he showed it to me very proudly. And I looked at it and I flipped through it a little bit, look at the main thing, score, you're very nice, you really, really nice results. You realize half your thesis is wrong? Like, what? And you shouldn't necessarily have this much fun, but he's like, what? Half your thesis is wrong. I knew he was referencing a certain paper, and that paper says we assume that when you divide, that k was an even number, and when you divide it by 4, the remainder is 2. If the remainder is 0, you have to add in a minus sign. It takes about a minute to fix his thesis. He dropped a minus sign in half the cases. But I knew that there was a paper that he was using which explicitly said, we're only going to assume k has a remainder of 2 when you divide by 4. If k has a remainder of 0 when you divide by 4, you have this trivial modification. You've got to be very careful whenever you look things up that you use the right stuff. And so depending on which source you use, they will refer to things differently. So physicists sometimes use theta coming down. I am more used to that. I will try not to use that. So here, wow, this became a really large picture. So I will rescale the picture a little bit. Okay. That should be a big enough picture. All right, so this should be closer to what we're used to. And now you have phi is the angle coming down from the z-axis. Okay. The radius, so rho goes from 0 all the way up to infinity. And it's always going to be a non-negative number. What about phi? When you're coming down from the z-axis, how far down can you come?
0 to pi.
0 to pi. Because you're not going to come all the way down and then come back up. So if you have a giant sphere, once you go down 180 degrees or pi radians, you're at the South Pole. So unfortunately, not all the angles are equal in spherical coordinates. Phi is going to range from 0 to pi. Once you come down, then you go around parallel to the xy plane. How far around do you go there? 2 pi. And so now you can see why we're using a new letter rho for the radius. Why do you think we use rho?
Another R.
Yeah, it's another R word, right? In Greek, rho is the R. The advantage of using rho is that if we come down by phi, then the height, the z, is going to be rho cosine phi, And then the amount we're coming out is rho sine phi. This is going to be the radius r as we're going sweeping around. So little r is rho sine phi. And now, here is your rho, this is your little r, rho sine phi cosine theta, and then rho sine phi sine theta. So it's really now like polar coordinates, except for polar coordinates, you need a radius. The radius is not r, the radius is rho sine phi. So people asked about converting from cylindrical coordinates to Cartesian coordinates. You would never really do that. You know, we normally shift things to cylindrical coordinates because they're nicer to work with. And so you'd be going in that direction. So if I give you something, we would want to convert it to cylindrical or spherical. Now, I think everybody knows what the word hyperlink is. So by doing this, if I now just click on this, it should actually open my browser and take me directly to that. You know, whenever you use a figure, you want to give references. You want to say, where did you take it from? This I did not do. I just stole these by doing a quick Google search. But here, if I actually want to see more, if you want to see more, you can now just click on this, and it will take you to the Wikipedia page on spherical coordinates. Okay, so if I give you something such as, let's see the size. Okay, good. X squared plus y squared plus z squared minus 3xyz equals c. So maybe this is some level set. Are we happy about this? Are we excited about this? Does a coordinate system scream out for us? There's going to be a lot of symmetry. I can switch x, y, or z any order, and it's not going to change whether or not the point is on it or not. X squared plus y squared plus z squared looks a lot like spherical coordinates. What is x squared plus y squared plus z squared going to become?
Sphere.
Well, in spherical coordinates, what would x squared plus y squared plus z squared become?
Oh, rho. Rho squared.
Well, rho squared. So does everyone agree that the first three parts, the x squared plus y squared plus z squared, is just rho squared? You could do it the long way. X is rho sine phi cosine theta, square that, add rho sine phi sine theta, square that, and then add z, which is rho cosine phi, square that. And when the dust settles, you'll get rho squared. Or you could just say, well, yeah, no, you know, this is what a sphere is. You know, if you're on the point x comma y comma z, then your distance is rho from the origin. What about minus 3xyz? That's more involved. Can somebody tell me part of what xyz would be? Or I can do it.
Oh, it's like it's not the cosine theorem, like part of the cosine theorem. I'm thinking because like what with the law of cosine, that's two.
Right, it's not going to be that. I can start doing it the long way. It's going to be a rho sine phi cosine theta. That's what x is going to be, right? Then I could do rho sine phi sine theta, which is what y is going to be, and I could do rho cosine phi. And then this whole thing would be equal to c. So I could do something like that. This is not going to simplify beautifully. I will be able to say I could pull out a rho cubed, but it's not going to be anything that nice. And so this is all you need to do when you're converting back and forth. You have your tables. So in polar, we have x equals r cosine theta and y equals r sine theta. And so if I give you an x and a y, this is how you would replace them. So if I gave you x cubed minus 3xy plus 17, well, what would x cubed be? That would just be r cubed cosine theta cubed minus 3, well, xy, I know I'm going to have an r squared. I get an r from each one of them. And then I would have cosine theta from the x and sine theta from the y. plus 17. And if I wanted to, I might be able to do some kind of angle identities. Maybe I could replace the cosine theta, sine theta with 1/2 sine 2 theta to try to understand things a little bit more. But this is how you would do the substitutions. So all you need to do is you need to have your conversion table. You can go the other way. If you want to go the other way, you would have r is equal to the square root of x squared plus y squared. And you would have theta is equal to arctangent of y over x. Okay. Any other questions on conversions? Now, what are the prerequisites for this course?
5 or 4 on AB Calc.
Okay,
That's 140.
Math 140. So what material is it illegal to assume that you know?
Linear algebra.
Wait, I can assume you know linear algebra?
No,
You said it's
legal.
Oh, I said is legal.
Oh.
I was really excited for a moment. Boy, was the semester going to change. No, it is illegal for me to assume you know linear algebra. Well, let's see if Caleb, this is calculus 3. What classes do you think are prerequisites for calculus 3? What classes do you think you have to take before you take calculus 3? Calculus 2, anything else? Thank you, okay? Really obvious, right? You are supposed to know Calc 1 and Calc 2. So on the first exam, which I think will be next Friday, Calc 1 and Calc 2 is fair game. If you are unhappy with my policy of dropping your lowest exam, please tell me. Unless I hear otherwise, I will assume you want me to drop your lowest midterm from your average. Yes?
Midterm will cover both chapters 11 and 12.
Yes, so it will cover up to what we've done today. I might give you a really basic simple limit. I might give you some simple integrals or simple derivatives from Calc 1 and Calc 2. Who likes partial fractions? Is there anybody who likes partial fractions? I can give a personalized exam.
So partial fractions.
Yes.
Oh, yeah.
Oh.
I don't like it, but I mean, it's fine. I mean,
Okay,
it
so
was never-
unless I hear otherwise, there will not be partial fractions on the,
Okay.
okay, trig substitution. Anybody a fan of trig substitution?
Please.
So if you would like trig substitution, please let me know so I can personalize the exam for you. Okay? Use substitution. Yeah, I was going to say, if you don't give me use substitution, then all of a sudden, partial fractions and
Has to have-
trig substitutions can come back in. Integration by parts. Yes, you have to allow me that. Okay? Is it acceptable not to be able to find a derivative?
No.
Why? What's different about differentiation and integration?
Not that, it's like you're taking.
Oh, they're very different. So I don't know if you've been told the big lie of Calc 2. And this is recording. So in Calculus 2, you leave with the impression, and I'm sorry, I'm going to be destroying your life. The tooth fairy is real, Santa Claus is real, don't worry about stuff like that. You cannot integrate. You may think you can, but you cannot. If it makes you feel better, I can't integrate either, nor can any of the professors here. We can integrate a few very special, carefully chosen functions. Most functions do not have a nice antiderivative. And so we have to really work to give you functions in Calc 2 to integrate. And then you feel, oh, I can integrate, I can do so well. No, we're very careful in what we give you. Differentiation is completely different. Whatever I give you, you can keep chipping away with the rules we have and you will get it. So if I tell you I have the cosine of x squared plus 3, what rule do you think you're going to use when you have the cosine? Yes. I changed the function a little bit. So let me just make it a little bit larger. So whenever you hear the word of, you should be thinking chain rule. Right? So how would we take the derivative of cosine of? The derivative would be negative sine x cubed plus 2x plus 1 times the derivative of x cubed plus 2x plus 1. So it would be negative sine x cubed, thank you for minimizing it, plus 2x plus 1. And then I might just write slowly x cubed plus 2x plus 1 and put a prime to then say, I now take the derivative of that. Okay, and then the derivative of that is just going to be 3x squared plus 2. So is everybody comfortable with taking a derivative like this? All right, well, this is the day on using Mathematica. Take D around this. What do you think D is going to do? Hopefully.
But isn't that the same for 3? No, but that's for like 3. But that's the same thing if you do a lowercase d, right?
So if I do D,
If you like typed in lowercase d, would it come up with the same thing?
yeah, both of them should return garbage. And D returns garbage, capital D returns garbage. Anybody have any guesses why D is having trouble?
Derivative function is on Mathematica.
D is, I believe, derivative.
Is there no semicolon?
No, that just means I actually wanted to show the output.
Capital C on cosine?
Nope, that's actually good.
Okay.
What if I change the function a little bit? This is a hint. Yes.
It doesn't know what to take the derivative.
It doesn't know what to take the derivative with respect to, right? Could I have my variable be happy face? Could I have my variable be dancing Kayla? Absolutely. So if I go like this, if I put a comma, I now tell it what derivative I want it with respect to. I want the derivative with respect to x. Okay? You can take derivatives very simply. So when you're doing a homework problem, is there any excuse for getting a derivative wrong? No, you can check your work. If you have multiple people, you can say, I'll check problem 1, you check problem 2, you check problem 3. What about finding antiderivatives? So integrate, let's do x to the 4th, let's do x squared plus x. And it's telling us no go. So what do you think the mistake is here? I'm sorry? So integrate called with one argument, 2 or more arguments are expected.
Because you put a space after that?
No, actually, I actually tried to write it like this. And then it's putting in that red arrow. It's basically trying to tell me I'm forgetting something.
You need to integrate over something.
I need to integrate over something. Or I could do the indefinite integral. But what if I gave you this function? What's the issue now? With respect to what, right? We want to be very respectful. For extra credit, this is the 80s trivia. Who's the comedian who goes, I no respect, I get no respect? No. It was 2 a.m. There was a fight in the house and the wife goes to the kids, shh, you'll wake up daddy. No respect.
They lose you in the office.
Well, it's fine that they allude to it, unless you can give me the name of the person. Kayla, you want the extra credit? He goes back to school. You forget his name? It was the dad from Back to School. Yes. Rodney Dangerfield. Back to School, I'm willing to show this. I thought it was a comedy when I was young. It's actually a documentary on higher education as to just how things really are. The strange college roommate is actually Warren Downey Jr., who eventually becomes Iron Man. It's one of his earliest roles. So we might watch that movie later. If I put in an X, it's now integrating with respect to X. And now it understands what to do. What, instead of integrating with respect to X, that's the indefinite integral. Maybe we want to integrate from 0 to 1. And you just do it like that. So the commands aren't that bad. Okay? Yes?
For next week,
For Monday?
And for the test.
Yes.
will be in class or-
So I'm not sure if the test will be in class or if it'll be a take home on the honor system. Do people have a preference?
in class.
Take home.
How many people want to take home?
Are you kidding me? Take home is no time.
No, it would be the same amount of time,
Take home you
but you would have the flexibility. You would have the
Yeah.
flexibility.
Yeah, you're flexible. to see.
Yeah, but if like on Friday if you're busy then.
Well, you could take it during class
still take
time.
it during
You can
class
still take it.
time.
I will make sure that everybody has the exam. Do people want to have, and then you would have the freedom of when you can take it. All right, I will trust everyone not to cheat. All right, so it will be a take-home exam, but it will be a timed exam. What you can do is if you want is after the 50 minutes, if you want to switch to a different color, different page, and then just keep working just to give me a really good data set, happy to do this. This is meant to be a diagnostic exam, okay? It cannot hurt you unless you tell me don't drop my lowest score, okay? Yes.
But you said it was gonna cover chapters 11 and 12. But we
No,
haven't.
that's the midterm.
Oh, the mid. Oh, okay.
Right.
That makes so much more sense.
Right.
Okay, so.
So
what-
basically, everything we've done up till today is fair game. Vectors, cross products, determinants of small things,
Right.
derivatives, antiderivatives, yes.
What about partial differentiation? So we touched on it in the
No.
first class, but it's the next lesson.
Right, well, I mean, if I give you partial differentiation, if I gave you, this function over here and I asked you to differentiate with respect to x or with respect to y, you should be able to do that.
Right, but the whole, but.
I'm not gonna give you any of the advanced theory behind it. Yes,
So the test on Friday is a midterm.
yes, it's mid, so this is a wonderful expression, midterm 1, midterm 2, midterm 3. Yes,
Are we allowed to use Mathematica during these?
no.
Those were nice.
Yes, you cannot, no. So it is a closed book, closed note. If you can mentally connect with someone else, that's fine. Right? But this is really meant to give me a data point as to how things are going. Yes.
Will you send us some review problems so we can take a look?
Send me an email and I might send you some review problems. But basically, if you're having no trouble with the homework and you can do Calc 1 and Calc 2, you are fine. I do have a massive amount of Calc 1 and Calc 2 problems with solutions. So I would strongly urge you to try to do some of these. They should be on the course webpage, and I will try to find where they are on the course webpage. But again, you can now test using Mathematica some of your basic stuff. What we did today, the most exciting part, was the little program. You can start writing more advanced programs later. All right.
And then after we're done with the test, we just take it to your office.
Yes. So
Will we be having class next Friday or not?
wait 1 second.